So the most important other analysis is to check for each, to this level of family. So for each family, what is the coverage of, what is the phylogenetic coverage of diversity in that family? So we have the catalogue of life species list, and we have our whole load of NUIC files with species IDs, standardized species IDs in there, and we can match these together to see what proportion of species we have covered. So for that, we need to classify we need a list of the families. We need also need to go through all the NUICs and pull out species and determine which family they belong to, and then we can count these all up. So the same Perl script used for integrating this information. The output file is COL matched to catalogue of life matched to. Okay, so we have a list of lineages. We have starting with the species ID and the lineage for that species, genus, tribe, subfamily, family. So and then from subfamily to order. So yes, it looks like produced by parsing the catalogue of life. Or some other ranks, or these other basic ranks for catalogue of life. So that file of lineages is being read here, and specifically searching for the family, and the species ID is the first item, tab separated. These then stored in this hash. So storing by the family, and we are adding all the species IDs for each family. And just rearranging this, putting it into an array, and here go through each family. So for each family, pull out the list of species contained and split that list, split into a list, go through each species, and then check what has been found in the source trees. So next we need to determine how this was stored. So yeah, so we've gone through this again, gone through this previously. So for each year we have the list of tree IDs for each file. Open the file and read in the list of binomials that is stored into this object here. And we're checking that, so for all species of the current list of the current family, are they observed in that object, i.e. are they found amongst the terminals of the phylogeny database? If they are, then we do several things, increment this. So for each species, if it's found, we're going to make a new line with the species ID, what family it is, and 1 has been found. And if it's not been found, we're going to add a new line where the last column is a 0. And like so, we have the species ID, the family it belongs to, and we have a 1 or a 0 depending on whether it's been found amongst the terminals of the phylogeny database. The statistical analysis themselves are pretty simple. Perhaps I'll just go over the permutation which we've done. We have the all catalogue of our species as the first row. Second row has the family to which it belongs, and the third row is it present. So we have about 970,000 species in catalogue of life. and we can pull out a list. The family to which it belongs is the second column. We can pull that out as so. So I have 1,241 families listed. Yeah, I'm just reading some of my notes. I should maybe mention the first thought would be, let's find the outliers of coverage, and I realise that's not what we want at all, because if we have one insect family with, say, 1% of species covered in phylogenetics database, one other insect family with 99%, and the remainder of the insect families are nicely distributed between those, then we won't have any outliers, but we still have huge difference in the catalogue of life. So actually what I want to know is where does every family sit on the distribution. Make a new sample table. Number of columns is going to be all the permutations, and the number of the row is going to be all the species of catalogue of life. So we're going to permute coverage amongst all catalogue of life species. So basically what this means is this is all the catalogue of life species which are found in the phylogenetics database 60,200. So we're going to permute this number randomly throughout all of the insects species. We use the sample function to do this. So let's just do this. So this is a single sample where we have catalogue of life species, and the ones and zeros according to what is found have been just randomly redistributed amongst all species like this. And then we do that, say 1,000 or 10,000 times, and that gives us we can calculate then a simple p-value. So then for each family we find what are the indices in the table which correspond to species of that family, and we can get the observed count, which is the sum of the species present, and we can then go through all the permutations and see where the observed count sits in this random distribution and get a p-value and write that there. So the p-value, I haven't explicitly stated what the cutoff is. I've just given 1 star for 0.05, which would be too permissive, 2 stars non-significant. But generally, what I recommend is actually considering 3 aspects, not just the significant, the p-value, but also the quartile, where does it sit in the distribution, and the magnitude here. This will be better viewed in a Unispace font. So we have I scaled this according to the number of species in each family, and then this is what's been done in the phylogenetics database. So we have both the magnitude and the proportional. Consider both of these. Look in the supplement, which I'll find. So here's a supplemental table which is on the publisher's site. So we have more details on here. Family significance determined as just shown. These are the number of source trees they were found amongst total in that species according to Catalogue of Life. Now there is, Catalogue of Life is the best available, but it's still nonetheless, there's plenty of things missing out there. I found a bunch of beetle families missing, so generally I just rank this by total species count and just consider the largest ones. Species total, species in the phylogeny database, and therefore the shortfall, and what is the proportion and the quartile magnitude. You can view that here in the Unispace to get an idea, and also just listed all these source trees and even counts of how many from that family which are found in each phylogeny in the phylogeny database, and count of those species.